All right, hey everyone. So today, for this video, I'm gonna go over how to use the USGS streamer website. I'm gonna go over some of the different um, areas where you can get the information to answer some of these questions, what some of these buttons do. So let's go ahead and get started. So you're gonna want to access the streamer website, and it should be provided in your lab, but if not, it's up here on the left hand corner of my screen. So once you type in that website link, you're going to click go to map. Alright, so one of the first things that you're going to need to do is zoom into the Denver area. So in order to do that, you're going to use this little slider here to the right. And zoom in. I would carefully zoom in. You don't want to lose Denver and then have to zoom back out again. So just slowly zoom in until you reach the Denver area. All right. Once you zoom in close enough, you can actually click a different button. I usually like to click the identify because if you click downstream and actually accidentally click a river, it'll zoom back out. So I recommend once you're zoomed in, have the identify button clicked so you don't accidentally get yourself zoomed back out. So what I would do is zoom in all of the way so that you can see the details on the map. There we go. So we are zoomed in all the way to the Denver area. So one of the first parts of your lab is following streams from downstream and upstream. So you're going to be tracing them. So the difference between downstream and upstream is downstream follows a river or stream to its exit body, where upstream follows a river or a stream to its source. So, for example, I'm going to trace Clear Creek upstream, and what you'll see here is where all of that water originates. And that makes sense because our water in Colorado comes from our snowpack in the mountains from the winter. So again, upstream is the source and downstream is the exit body. It doesn't necessarily mean that it's flowing down or up. So that could be a little bit confusing to some people. So let's go ahead and clear that map and click the identify tool. So one of the things that you're needing to do is tracing a stream downstream. So we saw what it looks like, tracing it upstream to its source. Downstream, we're going to be tracing it to its exit body. So this is why I said make sure you have the identify tool clicked when you're zoomed in because it'll zoom back out for you. So I just traced the South Platte River downstream. So you can see it doesn't really flow down. It actually flows north, then east, and then south. So what you see here is where Cherry Creek ultimately exits to the ocean. You can see here it exits in kind of like the New Orleans area. And typically it's just one exit stream, not two, is what you'll see. But in this case, there's like a dam set up over here, which is why we see two exit streams for the Mississippi River. So that's going to help you answer some of the questions about what's the ultimate destination of a stream, which way does it flow. So for like South Platte, I would go, oh, it flows north, and then it flows east, and then it flows south to where it ultimately connects with the Mississippi River and then exits into the Gulf of Mexico over here. Okay, so that is part one of the lab. That's going to help you answer some of those questions. And once you kind of trace it downstream, you can clear the map, and then we'll have to zoom back into Denver. This is the part where most students complain that it gets a little bit of annoying where you have to keep zooming in and out. But that's just how the website works, unfortunately. Okay, so we're zoomed back in. Oh, there is one more thing. So for example, say we're tracing Clear Creek upstream. You can get a trace report, and let's just quick summary, and it'll tell you, you know, what direction it's flowing, the stream that you're looking at, the elevation, the total length of that stream in miles, where its exit body is. Um, you don't need to look at the political features, but it matters where you click that stream. So for like one of the questions, it's asking the two streams, the Cherry Creek and South Platte in northwestern Denver, use the trace upstream and trace report to describe these streams. So I would make sure if you're like looking at South Platte, you would click, you know, before or after that where they converge together with Clear Creek. That way you can get, you know, your trace report. I would do the summary report. You don't have to do detailed, and it'll give you information on like how many miles of streams that were traced upstream. Um, what else? The number of stream gauges there, and again where the exit stream is. And then you could either do the detailed report too. I forget which one is the one you need, but I think they're kind of very similar, so either one should do for the lab. Okay, so now that we know how to trace upstream and downstream and what all of those mean, we can clear our map, make sure our identify tool is clicked, and zoom back in to the Denver area. Make sure you zoom all the way in for the next part of the lab. So the next part of the lab, you're going to be looking at stream gauges. So stream gauges are going to be these triangles that you see along the rivers and streams on the map. So those are going to be your stream gauges. I had students kind of tell me that it's kind of hard to find these stream gauges. I would look at like one of them might be like South Platte, Inglewood. Here's Inglewood. This one I would say, oh, this one has to be the one at South Platte River at Inglewood. So once you use your identify tool and you click the stream gauge that you're being asked to look at, you click it, and it kind of tells you the station type, agency, site number, station name, again South Platte River at Inglewood, and the state that it's in. If you go to the stream tab, it tells you the name of what river it's a part of, the exit body, and if you do map click, it gives you the lat, launch, and elevation, which you'll actually need to for some of the questions. But if you click this link here, the NWIS web homepage, you click that link, it'll give you more detailed information about the lat, launch, and elevation, which is here. And here's your lat longe. And it'll also give you the drainage area, which you'll need for some of the questions. And what you'll also see here, and this is where you know that you're at the right gauge, the name will be up there. What you'll also see here is some of the available data at that stream gauge. So what you can see here for daily data, what's collected is temperature, discharge, specific conductance, dissolved oxygen, and pH. And it'll also tell you the begin date and the end date of when those that type of data has been collected. So for some of them, they've been collected since the 80s, and some of them have just started in the 90s. But the daily data seem to all have been going to at least today. Or discharge, I think it's calculated at the end of every day, so you won't see discharge until the next day. So that's where you'll see some of the data collected. And then the dates that they've been collected. So the next part is you'll be looking at daily data discharge. So what you'll need to do for that is click the daily data link. And you'll just want to select the discharge parameter. since we're only being asked to look at discharge. I think for some of them you might be looking at temperature and dissolved oxygen. So you can click temperature and dissolved oxygen, but for this case we're just looking at discharge. And we want a graph. So for my example, I'm going to be looking at 2017, April 1st, 2017, so that's my begin date, and my end date would be April 1st, 2018, so I'll put that end date there. So I'll make sure everything's selected. I've got just discharge, I just have my graph output, and then my beginning and end dates. And then you'll click the Go button. And then what you'll find here is your graph that you'll be answering some of the questions. If you click presentation quality, it doesn't really zoom in much more to the graph. So you can use presentation quality, or you can just leave it here. You don't have to click that link like it says in the lab. So what you'll be doing here is collecting, max and mins of discharge. So you can see here a min would be like 30, or sorry, no, like something around 25 cubic feet per second. That would be my lowest here. And where like a highest would be around like 1100 cubic feet per second. So again, that should be pretty easy finding the max and min values for discharge. Okay, so that's how you're going to be using those stream gauge data sets. So another thing that I kind of wanted to touch on was the relationship between temperature and dissolved oxygen. There is a PowerPoint that I uploaded that kind of goes through that relationship, but you'll be using some graphs on the relationship between temperature and dissolved oxygen. But yeah, so what I wanted to say about temperature and dissolved oxygen is that whenever you have a high temperature, you're going to have low dissolved oxygen. And then when you have low temperature or cooler temperatures, you're going to have high levels of dissolved oxygen. So we can look at, let's do this one as 28. Okay, it won't let me. So we'll do this one as 2019. And then we'll do this one as 2018 to look at temperature and dissolved oxygen. So here you'll see kind of like that relationship: high temperatures, low dissolved oxygen, low temperatures, high dissolved oxygens. So you'll see how the pattern of the graph goes peaked and then low with the colder months, where dissolved oxygen is the opposite. It goes down and then it goes up in the warmer or in the cooler months. So it's lower in the warmer months, or sorry, it's lower, dissolved oxygen is lower in the warmer months and higher in the colder months. And then of course temperature, we understand how that works. It's warmer in the warmer months and cooler in the colder months. But you can see that relationship on how they relate to each other. All right, so I feel like that covers the majority of that lab. If you have any other questions, please post them in the discussion section. I will be looking through them throughout the week if they are based on this lab. If you have any questions about the final project, email me about that. If you want to set up a Zoom meeting, let me know. I'm going to hold my office hours from 2:30 to 3:30 again. And of course, they'd be extended if more people show up. All right, so good luck with the lab, and let me know if you have any other questions. Bye.